All right, good morning, everyone. My name is Sri Narayanan. I'm a professor here at QSC. Welcome, first of all. We have two schools visiting us today. As you can see, STEM Academy of Hollywood and the Cedar Charter High School. So over the last year, we've been actually working together with some amazing teachers. Two of them are here, Leahy and David. And we've been trying to see how can we communicate some of the latest things that are happening in engineering, especially in electrical and computer engineering, which is where you are right now. I'll tell you a little bit more about that. And related to our high school students, and hopefully inspire them to consider, doing things in STEM and becoming an engineer or using these ideas as they are sort of planning their future, right? More importantly, we also want to kind of demystify some of the things that you are using day to day, whether it's your cell phone or generating TikTok or looking at autonomous vehicles. Everywhere you see and everywhere you are experiencing, right? There's electrical and computer engineering, computer science behind everything. So today, what we'll do is we thought as a part of this sort of experience as we were trying to put together, see some of the ongoing research that's happening here, so that you can firsthand experience what it is in the creation of it, and you ask questions, interact with some of the students that are actually like you, who were not that long ago in high school or undergrads in engineering, but also graduate students have not had enough. They wanted to get a PhD, so they're pursuing creating and these kinds of very innovative technologies that we'll all be using tomorrow, right? So welcome, first of all, taking the time today to come to USC. So USC, as you know, University of Southern California, it's a large university with a lot of different areas people pursue in terms of what they are learning, what they're creating in terms of research, from our engineering school to our medical school to law school, to music school, and everywhere in between. People are working across these fields. The USC Viterbi School of Engineering actually is like one of the premier engineering schools in the nation, in the world. And it's named after Mr. Andrew Viterbi, in fact, who himself is an engineer of great acclaim. You might have heard of this company called Qualcomm, right? He's one of the early pioneers of these cell phone technologies that we now take for granted. All the things, how do you capture and share information over the wireless sort of network, right? And then be able to do this efficiently. And all that is because of engineering advances. And he's like a pioneer. And he also sort of as an alumni of our school, he gave back and in gratitude, and the school is named after him.
He's a professor in our department.
That is true. He's also, in fact, his career started as a professor. In fact, he after his PhD became a professor at UCLA, did all these amazing things, and now he's a professor, presidential professor at USC, and guiding many innovations. We are actually in the electrical and computer engineering department. Engineering has many fields, right? Mechanical engineering, computer science, and electrical and computer engineering is one of the core areas of engineering. Everything from sort of the molecular and atomic level to spatial level, everything is covered by electrical and computer engineering. Beyond just generating and consuming power, like when you plug in, you get electricity, right? That's part of electrical engineering, but much more, right? How do you design these chips that are inside your cell phones? What's happening, to make cloud computing, all the forms work. What makes computers, right, work? All that is because of advances in electrical engineering. They study design and study circuits. They study how do you sense, process data, for example, like whether it is audio or images. Today you'll see imaging, looking into a person's body. How do you make MRI work, right? And so on. Electrical engineering is such a broad field. It covers so many different things now. How do you generate data? How do you communicate data? When you and how do you manipulate data? You'll see some things in this deep fake area, right? When you create something on Instagram or TikTok, right? What happens? How do you create it? How do you manipulate it? It's called signal processing. Any kind of data. How do you share it? All this is because of advances that keep happening in this field. So today, when you think about even 25 years or how old is the internet, it took, I keep hearing in 1970 when they were trying to scan one image and transmit to from Los Angeles to Washington, D.C. for a demonstration. It took 3 hours. I imagine, the advances that have happened. How do you efficiently capture and transmit, data, right? And images and audio and other things. So all this happens in engineering. Today you'll get a glimpse of that. And behind that is like, basic foundations in math and physics and chemistry, depending on that. But it doesn't stop there. We actually build things that are useful for society and makes people's lives better, whether it is in health, education, or generally, entertainment, whatever it is. So welcome. I'd like to introduce my colleague, Professor Richard Leahy. He's the chairman of the Electrical and Computer Engineering Department. And he will tell us a little bit more. But I also want to acknowledge, we've been collaborating on this project with IEEE. IEEE stands for Institute for Electrical and Electronic Engineers. It's a professional organization. It's a global organization. So all of us are members. And, it sort of, promotes, the dissemination of knowledge and so on. So they were very keen, particularly one part of that society is signal processing. Signal processing means signals are data that we day-to-day sort of use to manipulate. Like an example of a signal would be audio, right? Like it's a signal, it's an acoustic signal that I'm producing, you're processing, and you're making sense. Images, video, or another example. Measuring some of your physiological sort of activity like heart rate, right? Using EEG, that's another signal. So signals are everywhere. Even text that we send, it's a signal. And so signal processing worries about how do you acquire, process, manipulate, transmit, understand. For example, voice recognition. It's a signal processing application. So they were very interested in supporting this, and we thank them for supporting this project. We're all involved alongside an amazing group of teachers and advisors, including two of them that have brought you all here. And so we're super delighted to have you all. And I'm going to hand it over to Professor Leahy to welcome you.
Thanks, Sri. So good morning and welcome to USC and our department. I think Sri and our colleagues and some of our students have put together a really interesting day for you to explore various aspects of signal processing, image processing. As Sri was saying, electrical engineering, which is our home department, is a very broad area. And I think something of a mystery to a lot of people outside of our discipline. So one of the things I hope that you leave here with today is a better understanding of what we do, and hopefully a desire among some of you to join us. So perhaps I can ask, how many of you here are 12th graders? And do you all know what you're doing next year? Some of you? Any of you going into college to study engineering? One. Awesome. Excellent. And other things that you're interested in studying? Some of you interested in pre-med, is that correct? Wonderful, wonderful. So some of the things you'll see today are actually at the junction of those two areas. We're lucky to have our own MR scanner here, which you're going to see either this morning or this afternoon. I was just installed and opened earlier this year, and it's being run by our colleague Krishna Nayak together with Sri. I'm involved, Justin Holder, who I think is involved today. Right? Yep. So as I said, today you're going to see primarily things related to signal processing. This is an area dear to my heart because it's what I work on. My own interests are actually in medical imaging. So I've worked on methods for designing and making images for X-ray CT scanners, for positron tomography, which is an esoteric way of using radioactive materials to image what's happening in the body, particularly in folks with cancer. We work on MR imaging, and then we work on analysis of the images that come out of these systems to better understand how the brain is working, to help in diagnosis and treatment of disease. My own particular area of interest there is in epilepsy and treatment of epilepsy. So we do everything from that to, our friends in the electrophysics area of the department work on fundamental devices, so new semiconductors that go beyond the standard semiconductors we use in our cell phones and so forth, that have some interesting and useful properties. So outside of signal processing, we design sensors, we design computers. These things, pretty much everything in here is designed by an electrical engineer, from the central computing device, all the sensors that allow it to know which way up it is, where it is in the world, the communications with each other via either regular cell phone links or Bluetooth, or what else is in there, GPS, so you can position yourself in the world. It's really an amazing collection of technology that's in there, and electrical engineers are central to almost all of those technologies. Similarly, in computers, we design and build computers. Computer scientists write software and operating systems. We actually design the computers themselves. In robotics, we don't do the mechanics, but we do pretty much everything else. We build the sensors, the control, electronics, and importantly, the algorithms and the software that underlies that. We have actually our latest faculty hire, Samir Bansal, works in the area of computer vision and robotics. So he designed methods for taking video from a video camera attached to a robot to help it navigate smoothly through different environments. And then what else do we do? We work in applications that range from healthcare and human interactions, with both Sri and my main interests, through scientific discovery, scientific instruments, and analysis of data from instruments. We also have a lot of influence in the entertainment world, something that Sri also does, which maybe he'll tell you about afterwards. Communications is fundamental, right? So how do we communicate with each other via cell phones, over computer links, with satellites and so forth, and also in the defense industry, which is very central to a lot of the industry and the space industry in the local neighborhood here. So I hope you find today inspiring. We've put some time into putting together interesting demos for you, and so I think you'll get an insight that you can't get, looking at things on the internet or reading in classes. This is a great way to see the kind of things we do, and I hope some of you are inspired to study engineering in the future, and even hope some of you will join us here in the next year or two. So welcome again, and I'll hand back to Sri.
Yeah, and thank you, Richard. In fact, I'll say a few of what I do. So I'm interested in all things human, the interface between humans and engineering. For example, like my work over the last 25 years of voice recognition, right? Like things that make Siri and Alexa and all that stuff work. The whole AI stack is not just software, but also a lot of signal processing and mathematics behind that. How do you take an audio to figure out what words someone's speaking and what are they intending? What is this person's emotion and so on? That's an example. And Richard mentioned, working with Hollywood, right? One of the questions that we started working on actually 10 years ago is applying engineering ideas to shine a light on diversity and inclusion in media. You might wonder, hey, what's going on? What? For example, one of the things is like we want to know, how are people seen and heard in film and television? So can we use sort of computer vision, which is a part of engineering, which processes images and video and characterizes, who it is, what are they doing, where are they, how are they interacting? Likewise, audio processing takes audio and say who's talking when, how much are they seen. That way we can show, for example, we showed that women get only a third of the time on the screen. They only get heard third of the time. That also means how much money that they are given. So all these, we can put numbers to what is anecdotally said, right? And engineering can be everywhere. In fact, the UN is using our technologies to analyze the meetings to make sure everyone's voice is heard and how that impacts policy. So the reach of these kinds of engineering is above and beyond just technologies and widgets that we normally think about, but it's broadly connected to society in many areas. So I hope today, when you're seeing this and also experiencing the campus, you can, this will also trigger your imagination, make you sort of, consider all kinds of possibilities as you're thinking about your future. All right, welcome. And I'm going to introduce Kathy Kabong, who is the business officer of our Ming Chi Institute, part of our department, who's been instrumental in organizing and helping you welcome here. Thank you so much, Kathy, and working with our teachers. So take it on.
Well, thank you, Professor Narayana, and thank you, Professor Leahy, and welcome everyone. And hopefully, you guys are, ready for a very exciting and stimulating day. And I'm gonna share with you the schedule for today. So you're gonna go through 3 lab sessions: deepfake, music, and medical imaging. And you're gonna be meeting at 3 different places. So EEB 132 is where we are right now. That's where deepfake is gonna take place. And then music is gonna be in RTH 318, and medical imaging is gonna be at the Michelson Center. So if you can see, after the first session, we will come back to the outside of this building where you will be going on campus tour. And after that, we'll do lunch. Then you will resume to your 2 other sessions. And we'll have a soft closing here, which is very casual, just to check in with you guys. And then, then you guys are ready to go home. Any questions so far? And next, this is the schedule for today. I believe Rosita Charter High School, you guys have divided into 2 groups, and you will go through like all these different schedules. And can I have the members from the music group and is anyone from medical imaging here? Yeah, they are. They will just have someone to take them over there.
Okay.
Yeah. Okay, that's fine. I think they're waiting outside for the music group.
Yeah.
I've seen that. And I do have a map. That's fine. So can I have the teachers that are going to be leading the group up here to pick up the schedules and a map of the 3 area, just in case you guys get lost. We will make sure we always have someone to give you direction. But yeah, so. So this is your schedule and the map.
Right.
Yeah.
Deepfake, yeah. So in fact, so the deepfake will happen here, right?
Yes.
In fact, the professor whose work you'll see today in the deepfake, right? He in fact won an Emmy award for his technical stuff. So in fact, the impact is like in many directions.
From here to get here.
We have a student that will bring you guys over. Yeah. Okay. So if you let me grab the team. I think they're waiting outside. Okay. So if you're deepfake, just stay here. And music. Yeah, so here's the bag for you. And if you are in group 2, please do follow.
Your folks.
Okay. Yeah. So group 2 will be my advisory. Group one from Rosita is Ms. Dick's advisory and my period 2. But you guys have to get your those visitor screening forms for when you go to the MRI. So I'm going to that's from the kids from my
Yeah, so we are dividing the group.
Yeah, but even 1/3 is.
I know 1/3 is going to be. They'll figure it out.
I'm sure they will. So it's so absolutely. That's cool.
Yeah, I'm just going to I'll talk to Giannis.
Everything is just.
my advisory.
Because all the other all kinds of things. I said,
Right.
yeah, I said, go.
It's really impressive, like two in all of computer science.
Yeah. And I said, well, they don't know what I thought the news. It's on the news of USC today.
Yeah, well, it's not exactly
Yeah, I don't want to. Yeah, that's right. It's not popular science at tier 35, but I know. Yeah, it's also taken so much by that.
Have they arranged any like celebration or anything for it?
I don't know. It's okay. As long as I'm just one little bit of breathing room so that we could do all the things we're trying to do. I also hope in the IEEE organization because
Which one is that? You're doing?
23.
That's next year. Is that the one in India?
No, this one is in Rhodes, Greece.
Oh, okay.
So, today the meeting was at 5 a.m. and I'm like, and so Petra's, it's going to be great, but and my
So who's the general chair?
Petra's
We do
one.
the
Okay.
medical
And
imaging.
I'm the program chair. Athena is the program chair. Petra.
Oh,
And
great.
so we are, and it's taking a lot of time. And I'm still VP this year.
We have a lot of prizes for volunteers, so
Oh, there we go. Well,
be active.
Thank you guys. Thank you so much.
Thank
Have
you.
fun. Enjoy. Yeah, ask questions.